Good afternoon, everyone. Welcome back to the Solidity webinar presented by Nehemiah STEM Research. Hope you're all doing well. So yesterday we looked at events and advanced events in Solidity. Today we're going to be looking at constructors. And just to give a brief overview of what we're going to be covering today, we'll be diving into the fundamental concepts of constructors, like what it is and why it's crucial, and how to pass arguments to initialize your contract, the intricacies of inheritance, and constructor execution order. Yeah, so as usual it will be a live code demo, and then I'll break down what the code is doing basically line by line. Yes, so let's begin with some few definitions of what a constructor is, some of the characteristics and concepts that need definition in today's tutorial. So I'll start by defining what a constructor is. A constructor is a special optional function that is automatically executed only once during the contract's entire life cycle. At the moment the contract is created and deployed to the blockchain, then the constructor is automatically executed, but only once at the moment the contract is created and deployed to the blockchain. Its primary purpose is to initialize the contract state variables with initial values, often based on parameters provided by the deployer. Some few key characteristics of a constructor. The name must match the name of the contract exactly, so that's one key characteristic. Another is it is declared during the constructor, it's declared using the constructor keyword. So this is the keyword, and you can see it's already being suggested there. And it can be public or internal. So if you mark it internal, the contract becomes abstract, meaning it can't be deployed on its own. Another key characteristic, like when we're defining what a constructor is that it is executed only once. Then we have a few other terms that you may need to know or what they mean. Before we get into the demo, we have what we call inheritance. Inheritance is the ability for a new contract, a child or derived contract, to inherit properties, that is, state variables and functions from an existing contract, which is the parent or base contract. This promotes code reusability and logical organization. Then we have what we call parent constructor initialization. So like when a child contract inherits from a parent that has a constructor, the child contract must provide the necessary arguments for the parent's constructor. This ensures the parent contract is initialized correctly before the child's own initialization logic runs. And then we have what we call constructor execution order. So in inheritance hierarchies, constructors are always executed in the order of inheritance from the most base, that is, it could be the parent contract or the grandparent contract, yeah, to the most derived child contract. This order is fixed based on the is keyword. So there's a keyword called is, not the order they are listed in the child's constructor. Yeah, so let's look at a demo. Uh, so start with the base contract. So remember, the constructor has to be named exactly the same as the contract. You remember that parent constructors are always called in the order of inheritance. To overextend. Just go to the next one, but it's one sentence. So So in summary, what this constructor code is basically trying to achieve, it demonstrates two primary concepts: the syntax of constructors, how to write a constructor and use it to set up a contract's initial state, and then constructor inheritance. That is the two ways to pass arguments to parent constructors, which is B versus C. And most importantly, it proves that the order of constructor execution is determined by the order of inheritance, is being the keyword, not by the order the parent constructors are called in the child's constructor. D versus E. Now let me break down line by line what's happening. From line 5 to 10, from line 5 to 10, we've declared a contract named X, and then we declared a state variable of type string that will be stored on the blockchain. Of course, the public keyword automatically generates a getter function for it, so we can call the name to retrieve its value. And then we have the constructor string memory underscore name. So it takes one parameter, a string. The memory keyword specifies the data location for the variable. For now, just know that function parameters of reference type like string need that. And then name is equal to underscore name. So inside if you see inside the constructor body, inside the constructor body, it takes the input parameter underscore name and assigns its value to the state variable name. So this is the core job of the constructor, initialization. Then from line 13 to 19, 13 being the comment, so consider from actually to 20, it should be so 14 to 19. It's an identical contract to X, but with a different state variable, text, and parameter name underscore text. So it shows a common pattern. And then from line 24 to 28, contract B, that's the inheritance list initialization. So that line contract B is X input to X, Y input to Y. So that contract B inherits from both X and Y. So I was saying, so where I see is X, and then we have some strings in the input X, and then Y, so you notice how the arguments for the parent constructors are passed directly in the inheritance list. The values are hard-coded. So when B is deployed, it will automatically have name, which is input to X, and text, which is input to Y. This method is useful for fixed, unchanging initial values. Then from line 30 to, let's say, 37, we have contract C, which is a constructor initialization. So contract C is X, Y, so this contract also inherits from X and Y, but the inheritance list is empty. It just declares the parents. And then constructor string memory name, that's line 33. The constructor now takes parameters, which is underscore name and then underscore text. And then here X in brackets underscore name, Y in brackets underscore text. That is how you pass the parameters to the parent constructors. It looks like function modifiers and is placed right before the constructor's body here. So this method is much more flexible as it allows the deployer of the contract to decide the initial values at the time of deployment. And then from lines 42 I have some comments there. Okay, so these contracts D and E are proving the execution order. Both contract D and E inherit from X and Y in the same order, which is, you can see, is X, Y, same as here, is X, Y. So contract D calls X first in its constructor and then Y. Then E calls Y first in its constructor and then X. So despite the different order in the constructor, the actual execution order is always X then Y, because that's the order defined in the inheritance list, which is X and then Y. That's the order. So the order in the constructor is irrelevant. That's why I put this one differently, but it will always follow this list. So regardless of how I put this one, where I'm calling Y first, but it will follow this order in the inheritance list. So both contracts will have identical state, which is name, X was called, and text, Y was called. So let's this was just to sort of give an understanding. We can look excuse me. We can look at a more practical example quickly. Create another one. let me call this one demo. Should I? So just to use the same I'll keep it in the same file, just add it here. Okay, so I've included a demo contracts so that when we deploy we can, for easy testing. So this contract will basically bring it all together. It inherits from X and Y and also has its own state variable, count. And its constructor takes 3 parameters, passing 2 to the parents and using 1 for itself. The getDetails function is a helper to easily see the values of all state variables after we deploy. So let's compile again and then deploy it. So we have a name. Yeah. We should be seeing the count as well. Okay. Let's start with the demo. Say my demo contract. Hello interns. 42. Transact. count, I should be seeing 42. Yep. Name, my demo contract, text, login terms, and then when we do the get details, it should show us with the inheritance order those details. So if I call the get details, we have my demo contract, hello interns, and 42. Which is this exact order. The order of the inheritance and then the state variable of the contract. So yeah, so it demonstrates how the same contract can be initiated with completely different data, which is the power of using the constructor method. So this is how constructors work. I can input new data if I wanted to. Let's say token XYZ TXZ. Deployed. Is it this one? Yeah, the count is 1000. Get details should give us the same order, starting with the inheritance. Exactly. Yeah, so that's it for constructors. Thank you for tuning in. Please don't forget to like the video, subscribe to the channel, share the video with your friends, your colleagues. Yeah, thank you. Hope to see you next week back here. Have a blessed day.